Alright, for my project I looked at the effects of intrauterine position effects in swine. So what we're looking at with intrauterine position is the placement of piglets inside the uterus. So there's two main components to this. We looked at the effect of fetal proximity to the ovaries and the cervix, and we also looked at the effect of male-female ratio and adjacent fetal sex in the uterus. So the idea behind this is that fetuses may be exposed to different hormonal environments based on the sex of neighboring fetuses. So as I said, we're looking at the proximity both to the ovaries and the cervix, and then we're also looking at adjacent fetal sex. So as far as terminology goes, a 0M fetus is located between two females, 1M is located between a male and a female, and 2M is located between two males. The first study looked at the location of fetus relative to the ovary and the cervix and how that affects fetal growth. So in the study we removed the placenta units and then recorded position, sex, weight, and crown to rump length. So as a result, fetus is located at the ovarian end of the uterus, were the longest and heaviest. Fetus is located at the cervical end, were intermediate in size, and intermediate fetuses were the smallest. In this study, they did not observe any major effects of adjacent fetal sex on weight or length. Next, we looked at intrauterine position and reproductive performance. So we had a group of donor sows, and they were slaughtered at day 112 of gestation, so right before farrowing. The uteri were removed, and the piglets were delivered manually in order to record intrauterine position. And they only selected the females from this group, and they raised them in heterosexual littermate groups until they were 120 days old. And then after that, they moved them to unisexual groups of 6 until puberty was reached. And then after that, we recorded the reproductive parameters. So what they found with the different intrauterine positions, there's no difference in the length of the estrus cycle and the ovulation rates, and there's also no difference between age at puberty among gilts of different intrauterine position. What they did find was that standing heat was the shortest for the 2M females. This is relevant because you want the longest standing heat possible so you can accurately detect estrus and have a successful insemination right at the time of ovulation. And among all these sows, there was no difference in response to the back pressure test when detecting estrus. What they did find that was significant, though, was that pregnancy rates were highest for the 0M females. There wasn't a huge significance between pregnancy rates in 0M and 1M females, but there was a large jump of about 10% between 1M and 2M females. 0M females were also more receptive to male advances, and they mounted their pet mates more often. They also looked at frequency of fighting in gilts in intrauterine position, which is relevant if you have a group, if you're housing sows in groups. 0M females showed the lowest amounts of aggression and participated in the fewest fights, by about 15, which was significant. Of the fights they did participate in, the 0M females won the fewest amounts. And when observing this, the females were housed in groups of 6, and each pen was observed daily for 30 minutes for the first 35 days, and then 15 minutes a day thereafter. So conception failure can be really costly to a swine operation, so it's important to evaluate all contributing factors. So in this experiment, we looked at the effects of sex ratio on how conception failure works. And we looked at anogenital distance, which is the midpoint of the anus to the genitalia of the pig. And they also looked at body mass and crown to rump length. So what they found, there was a higher proportion, if there was a higher proportion of males in the litter, that resulted in a significantly larger anogenital distance for the gilts in that litter. And these females that were born into these litters with high proportions of males, they had a conception success ratio that was significantly less of those with litters with a high female ratio. And also gilts that failed to conceive on their first mating were more likely to be from litters with a high proportion of males. And this was significant when there were over a dozen piglets and 2/3 of them were male. So this is the implications of this. Producers could look at anogenital distance and litter sex ratio to indicate potential conception problems. They could look at these parameters and therefore decide which gilts to use as breeding stock and which to raise as market stock, market hogs. And the last thing we looked at was intrauterine position and the number of teats in pigs. So this has been looked at a lot in mice and rats, and the development of mammary tissue in these rodents is influenced by androgens. The androgens inhibit mammary tissue development. And in this study, we looked at the proportion of males in the litter because it was hypothesized that androgens from male fetuses could affect neighboring fetuses in utero. And again, they looked at body mass, crown to rump length, anogenital distance, and the number of teats on both the dam and the sire. Two variables were significant in this study: the number of teats on the dam, and then also the proportions of males in the litter. So this showed that the number of teats is a function of inheritance, but there's also some environmental influence in utero as well, as far as number of teats go. So if producers are looking to maximize the number of teats on their females, they could select for dams with either a large number of teats and those with a small anogenital distance to maximize